We're given a linked list. Each node has three things: a value, a next pointer, and a random pointer. The random pointer can point to any node in the list. It can also point to nothing. Our job is to create a full copy of this list. The copy needs new nodes in new memory. Every value must match the original. Every next pointer must match the structure of the original, and every random pointer must point to the correct node inside the new list. Copying the value and the next pointer is easy. You walk the list once and build a matching chain. The random pointer is the hard part. When you create a new node, its random target might not exist yet. That target could be a node further down the list. It could even be a node you haven't visited at all. So you can't just set the random pointer as you go. Here's the first idea. Do one pass and just create every copy node. Leave next and random empty for now. After this pass, every node in the original list has a matching copy somewhere. The only problem left is connecting them correctly. So now the question becomes, how do you find the correct copy for a given original node? You can't use the value. Two different nodes can share the same value. You need something that uniquely identifies a node. The answer is the node itself, not its value. The node object as a reference. In Python, every object has its own identity. Two different node objects are never treated as equal, even with the same value. That means a node can be used directly as a dictionary key. So during the first pass, build a dictionary. The key is the original node. The value is its brand new copy. By the end of the first pass, every original node maps to its corresponding copy. Now do a second pass over the original list. For each original node, look up its copy in the dictionary. Then look up the copy of its next node. Using the same dictionary, set that as the copy's next pointer. Do the same thing for the random pointer. Look up the copy of the original random target. Set that as the copy's random pointer. Two small cases need care. If the original next is empty, the copy's next should also be empty. If the original random is empty, the copy's random should also be empty. Both are handled with a simple check before the lookup. The code follows exactly this shape. First loop, walk the original list. Create a copy for each node. Store it in the map. Second loop, walk the original list again. Use the map to wire up next and random on the copies. At the end, return the copy that corresponds to the original head. The core trick here is using an object reference as a dictionary key, not its value. This works whenever you need to map original items to their corresponding new items, and the items themselves aren't reliably unique by value. The same trick shows up in graph problems, like cloning a graph. Anytime you're duplicating a structure with cross-references, this pattern is worth reaching for.